Hello everyone and welcome to the lecture series on R Microcontroller and Embedded Systems. Myself Professor Rohini Kallur, working as Assistant Professor in the Department of ENC, KLS VDIT, Haryana. We are doing module number 3, that is 22A. In this lecture, we have learned about the purpose of an embedded system. The purpose of an embedded system means why we want to use that particular embedded system. So, in the purpose of an embedded system, we have seen the different purposes such as data collection, data storage, data representation, data collection. Then we have seen how the data can be monitored, data can be processed, and the data whatever is received, depending upon that how a embedded system can be controlled using an actuator. Also, we ended it with a lecture with the topic called as how a device or a embedded systems application specific user interface can be used. Okay, so in the today's lecture, we'll be learning about the elements of an embedded system. So elements of an embedded system is nothing but whenever we use an embedded system, what all should be there inside that. So what should be there inside an embedded system? That is what is the current topic, today's topic. So we'll be learning for that particular thing. So the core of an embedded system. The core of an embedded system means it is the heart of the embedded system, which will be either a microprocessor or a microcontroller or a digital signal processor, or it might be a application specific IC or ASIC, or a programmable logic device, or it may be a commercial off-the-shelf components. So this is the core of the embedded system. The core of the embedded system means all the processing, all the controlling, whatever we want to do, that is done by these. This indicates that whenever I want to use a microprocessor or a controller or a DSP, then I need to be choosing a domain specific embedded system. So if a embedded system that uses microprocessor, then I'll be selecting a better microprocessor present in the given range. And if I decide to use a microcontroller, then I'll be selecting a microcontroller which will serve my purpose. So similarly, if the embedded system involves some signal conversion or some signal enhancement, in that particular cases, we'll be selecting a digital signal processors. And depending upon whether I want a memory, whether I want a programmable devices, then we'll be going in for a programmable logic device, that is PLD. And off-the-shelf components, if we want, we will be selecting that also. So this figure is actually a representation of what all should be there in an embedded system. So embedded system, as you can see, here we have system core, we have IO ports, we have supporting IC, and then we have output ports. Core communicates using the communication interfaces. This, whenever I get an input from the sensor via the IO port, communicating with respect to system code where it gets the data. Data is either stored in the memory or it will be represented. Then the system core uses supporting IC or a subsystem and then to generate an output. Output in the sense that it will be a control or it will be an action on an actuator that is performed. This what happens is the system whatever we have, the system core whatever we have, that always communicates using a communication interface, and using the communication interface the data will be shared in the system. Okay, so what happens is we need to be studying in detail in this particular module 3 about system, different types of memory, different different sensors and different actuators, as well as what are the other system requirements or other IC requirement for the embedded system. Okay. So this is a typical embedded system. A typical embedded system is a device which will be consisting of n number of elements such as your system core, IO ports, output ports, your communication interfaces, memory and other system components. Here we are talking about the actual components, that is the core of a embedded system. So this core of an embedded system may be a controller, it may be a processor, it may be a SIC or it may be a DSP. So the actual controller which acts as the master brain of the embedded system. So the center part which was there in the last block diagram, that will be used as a master brain, and here it might be a microprocessor, microcontroller, FPGA, TSP or ASSP. ASSP is nothing but application specific standard product. Okay, this might be a ASIC also or it might be a ASSP. Whenever I select an embedded system, it can be viewed as a reactive system. That means for every input that is generated, it has to be giving me an output, and it should be reacting with respect to that. So the control is achieved by processing the information coming from the sensors and user interfaces and controlling some actuators that regulate the physical variable. So keyboards, push button switches are the examples for your input devices. We know crystal displays, that is LCD, piezoelectric buzzers and something at all are the examples for the common user interface, output device for one particular embedded system. So the typical embedded system we have seen, it will be having a memory. So the memory of the system is responsible for holding the control algorithm and other important configuration details. So it will be storing the data used for the next purpose. Embedded system, the memory for storing the algorithm or configuration data is of fixed type. Okay, so program memory, and it is available for the end user with the modifications. This memory, that is program memory, whatever we have, this will be protected from unwanted user interaction, so it will be in a protected mode. And we have different types of memories which we will be studying in the module in the next slides, which deals with the one-time programmable memory, programmable read-only memory, UV erasable programmable memory, or electrically erasable programmable memory, flash memory, and so on. For the normal memory, for the working memory, we use SRAM and DRAM. SRAM is a static random access memory. DRAM is a dynamic random access memory. So this random access memory is used for the most of the systems as a working memory. What happens is, this is a temporary memory, so you will be doing the algorithms or you will be doing the operations and then it will be stored in the SRAM or DRAM. And apart from this, the block diagram had communication interfaces, which is essential for communicating with various subsystems of the embedded system to the external world. So the communication interfaces may be used to onboard external communication interfaces. So onboard interface comes under with the I2C, SPI, UART, parallel bus interface and so on. External communication, again it comes with the wireless interfaces like infrared, Bluetooth, the Wi-Fi and so on. So these are the communication interfaces what we will see in the coming slides. Coming to the first part, that is a core of an embedded system. Embedded system is nothing but it might be a microcontroller, microprocessor, DSP, PLD or commercial off-the-shelf components. So when we talk about the general purpose and the domain specific processors, almost 80% of the embedded systems are processor or controller based. So the processor may be a microprocessor or a microcontroller or a signal processor, depending upon the domain and the application. Most of the embedded system in the industrial control and monitoring applications make use of available microprocessors. So the domains which require signal processing such as speech coding, speech recognition, etc. We use special kinds of special signal processors. So first one is a microprocessor. So microprocessor is a silicon chip representing a CPU capable of performing arithmetic as well as logical operations according to a predefined set of instructions. In general, the CPU contains and logic unit and the working registers. A microprocessor is a dependent unit and it requires the combination of other hardware like memory, timer unit, interrupt controller, etc. for the proper functioning. So for microprocessors, we will be going in for some specific companies, Intel, AMD, and so on. From these companies, what is listed here, we will be getting a processor into the market. So when we talk about a general purpose processor and application specific processor, then we'll differentiate them with respect to this. So a general purpose processor is nothing but designed for general computational tasks. Whereas application specific instruction set processor, that is ASIP, are the processors with architecture and instruction set optimized to in or application requirements. So here the applications include network processing, automotive, telecom, media applications, DSP, and then control applications. Okay. Here the processor, general purpose processor it is. The general processor running inside a laptop or a desktop is a typical example for this one here. And the second one is here the general purpose processor will be manufactured in a high volume. That means the number will be too high. So because of which the per unit cost for a chip is low. Whereas here what happens is the microcontrollers or the ASICs are manufactured for a required amount. So the cost of this will be too high. Then coming to the side, a typical general purpose processor contains an ALU and a control unit. Here, what is required and what is not required, we will be having here the chip coming in with the application requirement. It might be having program memory, data memory separately. It might be having on-chip peripherals. It may be having a processor also. So here what happens is the next concept is microcontroller. Okay. So microcontroller is a highly integrated chip that contains CPU, scratchpad RAM, special and general purpose registers, then on-chip ROM, flash memory, the program storage, timer and interrupt control for the synchronization, and dedicated. All this will be there in the microcontroller. So microcontroller contains all the necessary blocks for the independent working. Whereas if you remember, the microprocessor was working in a dependent manner. Here, this has a greater place in the embedded system design in place of the microprocessors, and they are cheap comparatively and cost effective, and they are readily available in the market. So these are the companies which will view the microcontroller kit to the market. See what is there between microprocessor and a controller. Know that here it will be it is a chip the CPU which is capable of performing arithmetic and logical operations. Whereas here this is a highly integrated chip contains CPU, scratch RAM, registers, ROM, flash memory, IO ports, and timer and interrupt control. And this is a this is a dependent unit. It requires a combination of other chips like timers, program memory, data memory, and interrupt controller for the functioning. Whereas this side it is a self-contained unit and it does not require any external interrupt controller. Okay, so most of the time general purpose in design for for the microprocessor, this is application oriented. And this does not contain any I/O port. So the I/O port functionality needs to be implemented with the help of external multiple peripheral interfaces like 8255. And targeted for this is targeted for high-end market and where the performance is most important. Whereas this side has multiple I/O ports and it depending upon 8-bit, 16-bit or 32-bit depending upon what is required. And this is embedded or the microcontrollers are targeted to the embedded market where the performance is not that critical, okay, until and unless we talk about a hard real-time systems. And in the microprocessors we have limited power saving options compared to the microcontrollers, and this side in the microcontroller we will be having more power saving features. Okay, so this is what is about the difference between microprocessor and a microcontroller. Okay, so in this lecture we have studied about the two different components, that is microcontroller and microprocessor. Along with that, the block in the block diagram we have seen what are the requirements, and the requirement will tell us about we need a microprocessor core, microcontroller core, its embedded, its I/O ports, its timer control, its communication interface, its output port and input port, say sensors and actuators. And we also need the concept called as memory to store the data. Okay, so all this we have studied in this today's lecture. In the next lecture we will study the rest of the components of an embedded system. Till then, thank you.